A nose-wheel airplane tends to tolerate and even correct bad habits. But that doesn't mean that we, as aviators, should allow it. The tailwheel airplane, on the other hand, doesn't forgive poor piloting skills. The margins of error are narrower, so a higher degree of skill is required. When you fly an airplane correctly, the difference between a nose wheel or tricycle gear airplane and a tail dragger or conventional gear airplane is not that great. Aerodynamics doesn't discriminate when airplanes are in the air. It's only during ground operations and the takeoff and landing phases of flight where they differ. The biggest difference between the tailwheel and the nose-wheel airplane, beside the layout of the landing gear, is where the center of gravity, or CG, is located in relation to the main gear. In a nose-wheel airplane, the CG is in front of and close to the main gear, while in a tailwheel airplane, the CG is positioned behind the main landing gear. Also, in the tail dragger, the mass of the airplane is behind the main gear, so it wants to swing around to the front or swap ends due to the pendulum effect. Think of it this way. Pushing something is trickier than pulling it. Let's say you're pulling your wheeled suitcase through an airport terminal. You provide the forward CG, and the two wheels are following behind you. It's quite easy. Now, let's put a handle on the rear of the suitcase and try pushing it. You're the rear CG, and the suitcase will wander around and be really hard to steer. Practically speaking, because the pivot point is at the main gear, the tail dragger always wants to turn, or more correctly, yaw, into the wind due to the weather vane effect. So the pilot must use their flight controls judiciously to counter this yaw moment. To add to this weather vane effect, a significant amount of fuselage, including the vertical stabilizer, is exposed to any crosswind. If you taxi a tricycle gear airplane in a straight line and then step hard on the brakes, the weight of the airplane is transferred forward to the nose wheel because the main wheels are behind the CG. This makes it easy to maneuver the plane on the ground. Conversely, if you apply hard braking in a tail dragger, the tail will want to lift up because the CG is behind the main wheels. Because the mass of the airplane is behind the main gear, it wants to swing around to the front, or swap ends. The mass is also above the axle pivot point, causing the airplane to want to pendulum up, which could result in a nose-over or a prop strike. If the airplane is turning at the same time, that inertia can result in a ground loop. Braking technique is more critical in a tail dragger due to the pendulum effect. This simple fact of physics requires proper rudder and braking technique. For example, if you're taxiing without the stick fully aft, a quartering tailwind, and then you hit the brakes, you'll see very quickly how the pendulum effect works. The tail will pop up, pushing the nose of the airplane down, and once it starts, this pendulum effect can get to the point where full aft stick is not enough to stop it. We also call this the drop, stop, and flop method. Good brakes are essential. If you lose a brake while taxiing, you will likely have to shut down and push your airplane off the taxiway. Positive static stability is the characteristic of an airplane to return to its original attitude after flight control inputs or a disturbance, such as turbulence, upsets it. This also affects airplanes on the ground during taxi. The nose-wheel aircraft is inherently stable on the ground and tends to straighten itself out as it rolls along. But the tail dragger's negative stability on the ground causes a small diversion to get worse. The pilot must counter this with rapid application of rudder, as failure to stop this divergence will result in the airplane ground looping or swapping ends. The key takeaway here is to always be ahead of the airplane. When the airplane starts turning right, you need to be on the left rudder. Momentum is the combination of mass and velocity, or mass and motion. Inertia is what keeps it going. Momentum and inertia are related because the more momentum an object has, the more inertia it has as well. When taxiing or landing, an airplane has forward momentum. As soon as it starts to turn in one direction, it still has forward momentum, but it also has side momentum. Because airplanes have a lot of weight, they also have a lot of inertia. Our job as tailwheel pilots is to control the inertia and to keep the momentum going in the direction we want it to go. Environmental conditions are always significant in aviation, but none more so than wind, especially crosswind, during ground handling of a tail dragger. The pilot must also consider the effect of the prop wash, which can counteract or magnify the effect of wind over the airplane's elevator and rudder. There are 4 forces that create left turning tendencies in all piston-powered airplanes. As we add power for takeoff, our airplane wants to yaw left. This effect is more pronounced in a tail dragger for several reasons. P-factor, or asymmetric propeller loading, is the force of the downward moving blade of the propeller being at a higher angle of attack than the upward sweeping blade, meaning the downward sweeping blade in a right-turning propeller will take a bigger bite out of the air, creating more thrust and yawing it to the left. A nose-wheel airplane maintains a level prop shaft attitude on the takeoff run, so there's little P-factor during takeoff roll until liftoff. A tail dragger, however, is more adversely affected by P-factor because it sits at a higher angle of attack during the initial takeoff roll. Torque is the clockwise or right-turning direction of your engine and propeller, forcing the left side of your airplane down and putting weight on the left wheel, creating left turning tendency and yawing the airplane to the left. Most noticeable in higher performance aircraft, it also affects lower performance aircraft. A spinning propeller is a gyroscope. When you apply force to a spinning disc, the effect of that force is felt 90 degrees ahead of the direction of rotation, and this is called precession. When flying straight and level, this force is in equilibrium. But as soon as we change an airplane's attitude, we force the prop to rotate in a different plane. In the tail dragger, as the tail is being raised on the takeoff roll, this momentarily creates a shift in equilibrium. This force is being applied to the top of the propeller, causing it to be felt 90 degrees to the right with the resulting left turning tendency. A rotating propeller creates a clockwise rotation to the slipstream as it flows backwards over the airplane. This causes an asymmetric flow in a corkscrew pattern as it spirals and hits the fuselage and empennage, pushing the tail to the right and yawing the nose to the left. Many aircraft manufacturers have offset the vertical stab or engine to help compensate for this effect. The dreaded ground loop. You've heard of it, but what exactly is it? A ground loop occurs when directional control is lost. The weather vane tendency of a tail dragger, along with inertial effects, can contribute to a loss of directional stability. This is often caused by poor placement of the aileron or elevator in a crosswind or a tailwind, and can be exacerbated by poor braking technique. In a ground loop, the tail of the airplane usually passes the nose, swapping ends, and in some cases doing a full 360-degree circle. The wing will drop, and the wingtip and/or the aileron will scrape the ground. In the worst-case scenario, the tail will pendulum up and cause a prop strike. To avoid a ground loop, the pilot must respond to any change in direction immediately while sufficient control authority is available to counteract any unwanted movement. This means that the pilot must anticipate the need for corrective control input. Ground loops don't usually result in injuries, except for a bruised ego and a hit to the bank account as a result of damage to the airplane's wheels, landing gear, wingtips, ailerons, and sometimes propeller and engine. Sure, there are lots of forces at play, but don't worry. Pilots have been flying airplanes with tail wheels since the beginning of aviation. The challenge and reward is the payoff. And you can always go by my credo, if they can do it, I can do it. So, now let's learn how to taxi, take off, and land a tail dragger safely in the hopes that you never ground loop one.